Okay, class. So let's continue. Let's continue with the class, right? So now the computation of f calculated value. The computation of f calculated value, we have treatment mean square divided by residual mean square, right? So let's mute ourselves now, right? Treatment mean square divided by residual mean square. I will say treatment mean square is the same thing as treatment sum of square divided by degree of freedom of treatment, right? Then also we say that to get the treatment sum of square that we are expected to have, you know, each treatment together. So we can now say that treatment sum of square will be equal to the total of first treatment is 33.6 square plus the second one, which is 41.6, sorry, 41 point square plus the C1, the TC is 33.7 square, right? Plus 34.1 square, right? 1 square. All over. Now, if you notice this question here, the number of treatments is the same. The number of treatments is the same for all. We have 1, 2, 3, 4, 5, right? It's the same. So I can say this divided by 5. But in a situation whereby the number of treatment is not the same, that you are expected to divide this small n with each treatment. But in this scenario, everything is the same. Minus that. Don't be confused. So everything minus correcting factor, which is that G. So correcting factor here, we have the grand total is 142.6 square divided by or class, sorry, let me write it like this for better understanding. Let me write it like this. Let me write it together. So let's say treatment sum of square. So we have 33.6 square plus 41.2
If we don't call
plus
you, come back from office, so from shop. I said if I don't call you, if I come back from shop.
minus, right? Minus correcting factor. Correcting factor is equal to 142.6 square divided by 20, n divided by 20, right? So now, what is square root of each value here? What is square root of each value? 33.6 square. Here I have 1128.96 plus 41.2 square. I have 1697.44 plus 33.7 square. Here I have 1135.69 plus 34.1 square. Here I have 1162.81 all over 5 minus correcting factors 142.6 square. Here is equal to 2334 minus 2334.76 all over 20. all over 20, right? All over 20. So let's bring it up. All over 20. Then add this together, we have 1128.96 plus 1674.44 plus 1135.69 plus 1162.81. Class, here I have divided by 5 minus 2334.6 divided by what? 20. So I just carry this value here, class, here, because I know we have reflection there. I just carry this to the side. Now, for the treatment, sum of square will now be 5124.9 divided by 5. Divided by 5. Here I have 498 minus 2334.76 divided by 20. Plus here I have 1016.74. So the treatment sum of square class will now be 1024.98 minus 1016.74. Class, I have 8.24. My treatment sum of square is equal to 8.24, class. 8.24. So now, if treatment sum of square is equal to 8.24, then I can easily get my treatment mean square based on the formula. So the treatment, since or recall that the treatment mean square is equal to treatment sum of square divided by k minus 1, right? So if treatment sum of square is 2, 4, now how many treatment do we have? We have 4, class. Remember, we have A, B, C, D. A, B, C, D is 4. 4 minus 1 will give us what? 3. So 3. So the treatment mean square will be this divided by 3. Then we have 8.24 divided by 3, class. So here we have 2.75. Let's say in 2 decimal. 2.75. So the treatment mean square is equal to 2.75. Now, what else do we need? Residual mean square now. Residual mean square. So for us to get residual mean square, this is treatment mean square. So now, the residual mean square, which is equal to residual sum of square over this. Abi, residual sum of square divided by n minus k. And also that if I have the residual sum of square, we can get residual sum of square by total sum of square minus treatment sum of square, right? Minus treatment sum of square. Now, we've gotten treatment sum of square. And recall that to get total sum of square, it's summation what? Y square minus correcting factor. And we've gotten the correcting factor now. We have the value for correcting factor as well. So let us get this first value. So this first value here is giving us, please let's do this together. Now we are expected to sum each value, right? Minus correcting factor. The first value there is 5.5 for a square plus 6.6 square plus 7.4. Please be punching the calculator like that because of time. Then 6.9 square, right? 7 7.2 square. 7.2 square, right? That's for A. Then for B, 7.9 square. Then 8.8 square plus 9.9 square plus 8.3 square, 6.3 square, then 6.1 square, 7.3 square plus 8.4 square, 5.9 square, then 6 square. The last one, 5.8 square. Please, somebody to help us do 5.8 square plus 8.5 square plus 6.7 square, 7.5 square, and the last one is plus 5.6 square. So all minus corrective factor. Class, what's the follow of our corrective factor now? We have
One
10.
142.6.
No, corrective factor.
Yes,
Corrective factor.
142.6.
No,
No, what?
1016.74.
God bless you. So I was surprised. This is corrective factor. Remember, corrective factor is 142.6 to the power 2 divided by 20. So this is corrective factor. So somebody to help us do summation y square that you are expected to sum each value, give it to us, then add them together minus corrective factor will give us total sum of square. I'm waiting, please. So TSS is what is the summation of this? Before you minus, we just sum this, then we minus it with that corrective factor. Class, who is helping us, class? Hello? I'm waiting for us, please.
Somebody is typing on the chat. Maybe you can share too.
Okay. But we need to be sure that the value given to us is correct. So we need to also
Okay,
cross check.
I got 27.98.
Okay. Ah. Abigail, what's the total? Abigail is just giving us somebody said 27.98. I don't know. So 27.98. Ah, I don't think it's correct. Even 6 square here will be 36. You know, we have 6 square somewhere here.
No, I mean after getting the whole sum of squares minus the correcting this thing, the total sum of square is one
Right now,
zero.
so give us the way it is. Just don't let us do it like that. Just give us the total, the
Okay,
value of this. Then
total value of the sum of squares is 1044.72.
1044.7.
Two
Okay.
point
I think
seven two.
Abigail is also helping us. So please confirm. So we have minus 1016.74, right? So if you do this, if this value is correct, then the total sum of square will now be 144.72 minus 1016.74. Everyone, thank you very much. So here I have 27.98. 27.98. Abigail also confirm, and somebody can also confirm if we are checking with us, right? So, this is total sum of square, which means I can easily get my what? My residual sum of square, right? I can easily get my residual sum of square. So, the residual sum of square is equal to this, right? Our residual sum of square will now be 27.98. Class, what's our treatment sum of square? What's our treatment sum of square?
8.24.
No, 8.24. I say 8.24 is not the treatment square.
The treatment sum of square, though I calculated my own, I got negative 97.89, but I know that it's quite a bit different from your own, because there's one place that we didn't arrive at the same figure, but I didn't want to argue that because I didn't want to say maybe it's correct or not.
Okay, thank you. Somebody say this is correct. Yes. Now, what I'm saying is, before we say treatment mean square, we have this divided by one value. So what's the value of it? You know, this one is divided by 3. Before that divided by 3, what do we have? What do we divide by 3? Because this one is k minus 1, right?
That is, we
So what?
divided 8.24 now. 8.24 is the treatment sum of square. TRSS is 8.24.
Okay, 24 divided by 3. Okay, so that means treatment mean square is 2.4.
2.75. Three times mean square is 2.75.
Oh, God bless you, my brother. So this is 8 point what?
0.24.
8.24. So which means residual sum of square would be 27.98 minus 8.24, right? I'm having 19.74 here. 19.74. So if this is 19.74, I can easily get residual mean square now. So the residual mean square will now be residual sum of square, which is 19.74. Remember that the total number of observation given to us is 20. 20 minus 4, we have 16. This will give us 16, right? For degree of freedom for residual. So Residual mean square will now be 19.74 divided by 16. Plus, I have 1.23, let's say 34 to approximate, right? So we have 1.234 plus. So to get the F calculated now, F calculated using treatment mean square divided by residual mean square. Now we've gotten the value now. My brother, what's the value of residual mean square again? Treatment mean square, sorry, 2.74, Abi. Am I right? Right?
2.75.
Okay, 75.
Yeah.
Thank you, sir.
As,
So 2.75 divided by 1.234. Right? Since we even have two decimal, right? Well, no problem. So now the F calculated now will be 2.23 class. The F calculated will be 2.23. That's our F calculated, right? 2.23. Now the next step is what? F tabulated. The next step is F tabulated. I don't know if we have statistical table with us. So, but I will advise you to get this ESON, EO, ESON, and RO or CAFO, right? They will allow you to take this to the exam or is allowed. So let's take note of this, that our F test, F calculated is 2.23, right? It's 2.23. So the next step is computation.
hello, sir.
F,
So why
right,
did you pin it now?
it's recorded. You will get the video after the class. You will get the video after the class. Now, recall that the F tabulated is significant into K minus 1 and N minus K, right? And I said that this is representing P1 and this is representing P2, right? So, and here we are taking 0.05 for 5%, K minus 1, which is the treatment we have is 4 minus 1. We are taking 3, right? For P1, we are taking 3. And for P2, remember that this is 20 minus 4, which is what? 16. Which is 16. So when you check your statistical table here, for 0.05, please take note that you are checking for percentage given to you. 0.05. Let me look for my home. Okay, you can see you have the one that started from 10, and now you can the one from 1 to 3 for P1, and you see the one for 1, 2, 3 for P2. Now, my home here, though this thing will capture it very well. You see something like P1, P2, P1, P2, P1, P2 here. See my P1, P2 here. And you see something like F, you see F here, F1, F2. So now for my P1, I'm checking 3 here for my P1. When you trace it down to where you have, 16, when you have 16, here I have F tabulated, for my own F tabulated, 16. Class, I have 3.2, let's say, let me approximate. What I have here is, without approximation, is 3.2389. This is what we have. So when you check V1 for 3 under 16, I have 3.2389 class. 3.2389.
It's approximated here for my own to be 3.24.
God bless you. You can see it's the same thing. It's the same thing. That's why I don't
It's
want to approximate.
3.24, yeah.
Okay. God bless you all. So we have this, we have this. So the next step is critical value. So the critical value can just have something like this. You can just have something like this, right? We shaded this. If you don't have a negative, there's no need for you to even have this. Some textbook we don't have this thing here. So we call this to be a rejection region, and we call this to be acceptance what? Just analyze this like this. What do we have? The first one is 2.3. Let me have 2.33 for calculated value 2.23, and for tabulated value we have 3.239. Right? You can just analyze it like this. Then the next step is decision. Now, under decision, it was the same for all tests that we have. Please take note that when the calculated value is greater than the tabulated value, you are meant to reject the HO. When the calculated value is greater than tabulated value, you are meant to reject the HO. And it's opposite also, which means when the calculated value is greater than the tabulated value, you are meant to accept the HO. So the answer here will not be since F calculated value is class. What we have here is less than F tabulated what? Value, right? We will accept HO at 5% level of significance, right? These are how we are going to analyze it. That since the F calculated is less than F tabulated value, we will accept the HO at 5% level of what? Significance. Take note. So the last part, which is conclusion now, I want somebody to answer this. If I'm accepting the HO and I'm rejecting the HO, what will be our conclusion, class? What will be our conclusion? Which you are getting this from the question. What will be our conclusion? Who can this class? Hello? Can I pause out? Since I'm accepting the HO and I'm rejecting the H1, what will be our conclusion?
Our conclusion would be that all areas of all the division are equal. Sorry, let me get the question.
There is no difference. There's no difference between the yield
Yeah,
power.
yes, sir.
God bless you. Because the question was saying something here that determine or test whether there is a difference in yield power, the accuracy, right? So if what we have is now showing that I'm accepting the HU, which means there is no difference between, let me write it out. No difference between fertilizers. Fertilizer. Class, any other question, please? Any question, please? Okay, so in the absence of none, this is where we are going to stop today. But in case if you have tried to study this after the video was released and you don't understand or you have one or two questions to ask, you can reach me on WhatsApp and I will explain to you better. I will explain to you better. So thank you very much for joining today. Essay, I don't know, is Essay there? Hello? Okay,
Hello, sir.
go ahead.
Before you go, please, let me get the formula for F calculated.
The formula for F calculated is this. F is equal to treatment mean square divided by residual mean square. This is the formula. And we further break this down. That treatment mean square is now calculated as treatment sum of square divided by sum of square, which is k minus 1. Right? And this is also the residual mean square is also break down as residual sum of square divided by degree of freedom residual. So all the information are there, and you can go through the video after the class. Are you okay with that? But
Mr.
before we
Brian, I
go,
have a,
class, before we go ahead.
my
Go
question
ahead.
is, if a question is given
Yes.
on this, so we should have it in mind that we are going to do all this in order. They will specify where for us to do all this calculation. Are they going to specify it, or once the question is given, we should know that this is what we are ought to
Yes.
do?
Yes, that's why I'm solving the past question now. And this is past question last step past. So it's like I have been asked to test between 3 or more variables. Only applicable test F test. The only applicable test is F test. So before, let me tell us how to derive an ANOVA table. Because sometimes you may be asked to transform your result into an ANOVA table. So ANOVA table, let me just try to manage the board. So here we have sources of variance. We have degree of freedom. We have degree of freedom. We have sum of square. We have mean of square. And we have F test. Let's just manage that. We have F test. Under the source, we have treatment. We have treatment. We have residual. We have residual, and we have total. We have total, right? We have total. So what's the treatment? What's the degree of freedom for treatment? We have k minus 1. The degree of freedom for residual, we have n minus k. So when you add this together, you give us the total, which is n minus 1. Maybe ask to fill the table. So the sum of square. Under the sum of square, the treatment sum of square. This is residual sum of square, and this is total square, right? Total sum of square, right? Total sum of square. And here, which is mean sum of square. Mean sum of square is the same thing as total sum of square divided by n k minus 1. Right, k minus 1. And for residual here, is the same thing as residual sum of square over n minus k. So this is treatment sum of square, and circle it like this, right? And the F test now, the F test will now be treatment mean square all over residual mean square. So class, this is what we call ANOVA table. This is what we call ANOVA table. In some question now, they can omit a value here and you'll be asked to fill the table. And in some question now, you will be asked to form the ANOVA table after you solve the question. So all the necessary information are like the question that we just solved now, you can transform the value into this table to get the F test. So this is what we call ANOVA table. So in the absence of,
The number 3 is what? The third one is what? That subheading.
The first one is source of variance, degree of freedom, sum of square, mean of square, and F test.
Okay.
Yes. Thank you very much. And
Thank you.